If you've worked in OT for any amount of time, you've encountered serial communications, even if you didn't think of them in those terms. That cable going into the COM port on the back of a PLC, the multi-drop wiring running between a row of meters, the RS-485 bus on your Modbus RTU network, all of that is serial. In this video, we're going to look at the three main serial standards that you'll encounter in OT, what they're each used for, and a specific security risk that shows up when serial devices get bridged onto an IP network. Serial communications predate Ethernet. PLCs, RTUs, flow meters, and protective relays installed in the 1990s and 2000s, and many installed even earlier, use serial as their native communications interface. Ethernet ports on field devices only became common relatively recently. So even in facilities that have modernized their control systems, you'll still find serial devices woven throughout the plant. Meters on RS-485, legacy RTUs with RS-232 config ports, radio links using RS-422. Replacing all that infrastructure is expensive and requires process downtime that most operations can't easily schedule. So serial isn't going away anytime soon. As an OT engineer or technician, you'll be working with it for years to come, and understanding where it fits relative to Ethernet is important. RS-232 is the oldest and most familiar. It's point-to-point, one device talking to one other device, and has a maximum distance of about 15 meters. You'll see it most often as the local configuration port on a PLC or HMI. You plug a laptop directly into the device with a serial cable to configure it. It's not designed for field wiring across a plant. It's a short-range direct connection. RS-485 is what most people mean when they talk about Modbus RTU wiring. It supports a multi-drop bus topology, meaning you can connect up to 32 devices on a single pair of wires, and it can run up to 1,200 meters. That makes it practical for connecting a series of meters or field devices along a pipeline or process unit. It's half-duplex, meaning only one device talks at a time, and the Modbus RTU protocol is designed around that constraint. We'll talk more about protocols and how they relate to networking later. RS-422 is similar to RS-485 in distance capability, but it is full duplex, meaning both sides can talk at the same time, and it's point-to-point. You'll find it less commonly in the field, but it shows up in some SCADA radio telemetry links and higher speed serial applications. Here's the security issue that comes up constantly with serial devices: serial to Ethernet converters. These are small devices that sit between a serial field device and an Ethernet network, translating the serial traffic so the device can be accessed over IP. They're common, they're inexpensive, and they solve a real problem. How do you remotely access a serial PLC that has no Ethernet port? That's what they're for. The risk is that a device that was engineered with no network connectivity suddenly has an IP address and is reachable from the network. The original device may have no concept of network authentication, no encryption, nothing. And the converter itself often ships with default credentials, or no credentials at all, because manufacturers assume it will be protected by the network. The mitigation is straightforward, but it has to be intentional. Treat the converter's IP address exactly like you would treat any other networked OT device. Put a firewall rule on it. Restrict which IP addresses can reach it. Change default credentials if any exist. And make sure every converter in your facility is in your asset inventory. If they're small, they get tucked into panels and they get forgotten. And once they're forgotten, you lose the security. Next up is video 7, the security consequence. We've now covered what networks are, how they work, and the physical layer they run on. Now we're going to talk about what it means for OT security when all of this is connected. That's where this course really starts to tie together. We'll see you there.